Question number 1. 3 students are asked to prepare sample of benzoic acid C6H5COOH from alkaline hydrolysis of methyl benzoate. Sodium benzoate is a salt formed as a result, which is then acidified with hydrochloric acid to form this C6H5COH. आप किसी भी साल्ट को अगर उसके अंदर दोबारा ऑर्गेनिक साल्ट की बात कर रहा हूँ, अगर आप उसमें एसिड ऐड करेंगे, इट वेंट बैक टुवर्ड्स द
बफर बनेगा,
towards the acid, right? So basically that is going to make acid bag. So in first case, this is going to react with NaOH, right? And this one is called hydrolysis, alkaline hydrolysis. Here is the formation of a salt, and then this salt is reacted with HCl, and then there is the formation of this one acid, that is benzoic acid, plus NaCl, normal salt is formed. The student used the following method, and step number 1, put 1.242 gram of the liquid methyl benzoate into 50 centimeter cube of round bottom flask. Number 2, prepare 100 centimeter cube of 1 mole per dm cube of NaOH solution. You know कि उसने पहले स्टेप में NaOH ऐड किया था, तो इन दोनों के सोल्यूशन उसने मेकअप किए हैं. थर्ड में add 10 centimeter cube of excess prepared NaOH into the round bottom flask. उसने 10 centimeter cube mix किया. Add some anti-bumping granules to the round bottom flask, ठीक है, ताकि bumping ना हो, smooth boiling हो. Fit a condenser on to make the reflux apparatus. He is doing heating under reflux reaction for 20 minutes. Allow the reaction mixture to cool and carefully pour the liquid into the beaker. फिर उसने उसको ठंडा किया और उसको एक liquid में add कर दिया. Acidify the liquid, उसके अंदर फिर उसने dilute HCl डाला उस liquid के अंदर. Filter the mixture formed in step 7, जो यहाँ पे बना था उसको उसने filter out कर लिया. Purify the benzoic acid by crystallization from the hot water, because this benzoic acid was soluble in hot water, but benzoic acid is not soluble in cold water. ये याद रखना है आपने. Filter dry and record the mass of pure benzoic acid obtained. तो इस तरह उसने उसको obtain कर लिया वगैरह वगैरह. Calculate the volume of benzoic acid used in step 1. Give your answer to the nearest 0.05 centimeter cube. Density of the methyl benzoate is equal to 1.08 gram per centimeter cube. So density is given, and he used 1.242 gram of the liquid methyl benzoate in 50 centimeter cube round bottom flask. So 1.248. 1.248. We know that from this answer that 1.08 gram is equal to 1 centimeter cube volume. This is what means by the density. So with the help of density, you can find the value of mass with respect to volume, or volume with respect to mass. So 1.08 gram of this liquid is going to have 1 centimeter cube volume, and 1.242, if I'm not wrong. Yes, 242, not 8, sorry. 242, how much centimeter cube will be there? Please let me know the answer. And that will be
1.15.
1.15 centimeter cube, exactly. A part 2, identify the suitable piece of apparatus to measure the volume of methyl benzoate required in step 1. We need volume in fraction. Which one apparatus is the good to measure the volume in fraction, 0.05 accuracy? That is the one and only, and it is
Pipette. Burette.
It's a burette. Pipette used, that is used only to measure the 25 ml overall, just 25 ml. Calculate the mass of NaOH that is needed to prepare a solution in step 2. mass of NaOH in step 2. So first of all, the concentration is given, volume is given. You can find the mole, then mole can be converted into mass, or directly you can convert into the mass, 101 mole per dm cube. So concentration is equal to mass over mr multiplied by 1000 if the volume is in centimeter cube. So the concentration is 1 mole per dm cube, 1 overall. Over here, you can see it over here. Yes, 1 mole per dm cube. And volume is 100 centimeter cube. That is 100 centimeter cube. And its MR of NaOH is 40, 23 plus 16 plus 1, 40. So overall, I think if I'm not wrong, I can multiply by this 100 with concentration 1. So 100 into 1 is equal to mass over 40 into 1000. So we can write that
4.
mass is equal to 4
4.
gram. Yes, that is, 40 multiplied by 1000 and multiply by 100, this one divided by 1000. 40,000 over 1000. Yes, answer is 4. So 4 gram of NaOH was used. Student, add the mass of NaOH.
सर 40,000 over 1000 तो 40 नहीं होगा?
40 into 100, 4,000 over 1000.
ठीक है सर.
ठीक हो गया. Student, added the mass of NaOH calculated in A3 into the beaker. Describe the steps the student should make 1 centimeter cube of 1 mole per dm cube solution. Give the name and capacity of any apparatus that should be used. Write your answer using the series of number of the step. So there is the basic main sequence, generally speaking. First of all, we are trying to dissolve this solid into the aqueous solution. So as I need to make it 100 centimeter cube, so I will take the conical flask of, measuring flask of 100 centimeter cube, and I will add this quantity that is equal to 4 gram. 4 gram of is transferred to the volumetric flask, and then I will add water. Let's 20 centimeter cube 5 times while shaking the whole container. So basically, as far as my opinion is concerned, in one, we want to dissolve that sodium hydroxide, 4 gram sodium hydroxide will be added into a volumetric flask. That is having the capacity of 100 centimeter cube, right? That volumetric flask, is having only one mark of 100 centimeter cube. And then we will add water, especially distilled water. We will add distilled water in, let's suppose, 5 portions. As far as my opinion is concerned, in 5 portions, 20 centimeter cube each. And we will shake it or stir it, shake it continuously. So there must be the continuous shaking. And first of all, number one, we will add 4 gram of NaOH. We will transfer the 4 gram of NaOH into the, you can say, transfer into the volumetric flask. Or there is another method. You can add, you can make this 4 gram into, step number 1, and here I'm going to add step number 2. There is another method that is accurate method, by the way. 4 gram NaOH plus some water. If you are going to make its solution initially in a beaker, then this volume, this solution will be transferred into the conical flask. 4 gram NaOH solution will be transferred. You can change it like that. Solution will be transferred into the conical flask. So you can say that is step number one, sorry, not two. It's step number one, it's step number two, and this is a step number three. Then you will add the small amount of water in 2 to 3 to 5 portions, and every time you are going to stir it or shake it just to know that there is a complete homogenized mixture or solution. So whenever you are having the solid, first make its solution in a beaker in a small container, then that solution is poured or transferred into the volumetric flask. Then there is the addition of further water to make it to the required level, like 100 centimeter cube. So that is the appropriate, in my opinion, appropriate way out mechanism to synthesize any solution of any concentration. C, student 2 prepared 0.1 mole per dm cube NaOH instead of 1 mole per dm cube NaOH in step 2. State how this would affect the final mass of benzoic acid form. Explain using calculation how you come to this conclusion. Methyl benzoate mass Mr is equal to 136 and benzoic acid mass is 122. Effect on mass, explanation. So once again, there is need to focus on it basically. Number one, we are supposed to find the answer of benzoic acid. In fact, initially we are using methyl benzoate. Yes, methyl benzoate, right? Number 1 mole of benzoate. This is the methyl benzoate, and we are going to mix it with NaOH, and this time, I mean, student 2, 0.1 mole per dm cube instead of 1 mole per dm cube NaOH. So it has decreased the concentration of NaOH. स्टूडेंट 2 ने कंसंट्रेशन NaOH की कम कर दी है. अब इसके लिए ये देखना ज़रूरी है कि क्या ये दोनों कंसंट्रेशन के कम करने से जो इक्वल मोल रेशो थी वो सेम रही है या कम हो गई है, कोई लिमिटिंग रिएक्टेंट तो नहीं बन गया. सो आई एम गोइंग टू चेक बोथ ऑफ देम एंड व्हाट इज द क्वांटिटी ऑफ this one, I mean, methyl benzoate and NaOH as well. So once again, let me check it over here. What was the volume of NaOH taken? The volume of NaOH was 100 centimeter cube. So this time, I mean, in case of, let me do the rough calculation first of all. NaOH concentration is 0.1 multiplied by 100 and divided by 1000. So here in this experiment, I'm using this number of mole. Let me know what is the number of mole, please.
Zero point zero one.
0.01 mole. And what is the mole of methyl benzoate? How much have we added it? We have added 1.242. So find the mole of methyl benzoate. 1.242 divided by its Mr 136. It's
9.13 into 10 to the power minus 3.
9.13 and 9.13. I'm sorry.
9.13 into 10 to the power minus 3.
Okay, just a minute. 136 is equal to 9.13 into 10 raised to the power minus 3. So which one is the lowest or the lower quantity?
Methyl benzoate.
Methyl benzoate.
Methyl benzoate. So yet it is a limiting reactant, methyl benzoate. Then is there should any difference on the formation of the mass of compound that is being formed? Do Do you think?
It is a limiting reaction.
In both
It is limiting,
cases,
so
No
it
effect,
should
I guess.
affect
no
it,
effect. Exactly. There must be no effect because in both cases, this methyl benzoate is acting as a limiting reactant. In both experiments, methyl benzoate is acting as a limiting reactant. So basically, yield is going to depend upon the methyl benzoate. So yield, mass will be with respect to methyl benzoate C6H5 C double bond O CH3. Part D, explain why it is necessary to reflux the mixture in step 5. हम रिफ्लक्स करते क्यों हैं? उसकी दो रीजन होती हैं जनरली. एंड रिफ्लक्स जहां पर भी हम करते हैं वहां पर हीटिंग भी लाजमी होती है. हीट के बगैर रिफ्लक्स यूज नहीं होता. आपने पढ़ा होगा, देखा होगा, सुना होगा, हीट
ताकि
अंडर
सॉल्यूशन
रिफ्लक्स.
वापस आ जाए और मतलब इवेपोरेट ना करे,
यस.
मतलब
नंबर वन,
हीट अप करके ऊपर.
हाँ जी, heating the mixture when heat is essential. Heating the mixture and keep the contents in the reaction mixture throughout that, keep the volatile contents, you can say, जो highly volatile liquid होते हैं, keep the volatile, especially this process is used to keep the volatile contents in the reaction mixture throughout the procedure. Out the process or procedure. So that is the basic theme. Number one theme is we want to heat the mixture. It is essential to heat the mixture. While we are heating, the basic theme is to provide the energy of activation, to increase the rate of reaction, heating the mixture to increase the speed, increase rate or speed, or to provide the energy of activation. जो भी आप लिखना चाहें सभी ठीक है. पहला पर्पस ये है. रिफ्लक्स बाद में लगाते हैं, पहले हीटिंग. वी नीड टू डू इट हीट. अगर हमें हीटिंग नहीं चाहिए तो हमें रिफ्लक्स बिल्कुल नहीं चाहिए. फिर इफ आई एम हीटिंग एनी सोल्यूशन, एनी कंपाउंड, एनी कंपोनेंट, एनी मिक्सचर, एंड इट इज हैविंग द वोलेटाइल कंपोनेंट, उसमें कोई भी ऐसा लिक्विड है जो हाईली वोलेटाइल है, लाइक एथेनॉल है, तो अगर मैं हीट करूंगा, मुझे हीट भी करना है और इसको रोकना भी है, तो फिर मुझे उसके ऊपर लेबिक कंडेंसर लगाना पड़ता है, दैट इज एक्टिंग एज अ रिफ्लक्स, ताकि वो हीट मिले, उनमें से जितने भी हैं वो रिएक्टेंट्स मॉलिक्यूल वो रिएक्ट करें एट द मोमेंट, और फिर जो अनरिएक्टेड हैं अगर वो ऊपर चले गए, इफ दे आर गोइंग टू बी चेंज देम इनटू द वेपर स्टेट, दे शुड बी कंडेंस्ड बैक टू द रिएक्शन मिक्सचर, तो वापस ठंडे होके वो दोबारा गिर जाएं. और इन दिस वे the volatile contents should not leave the reaction mixture unreacted. That is the basic theme, and you can report this theme into your own words more beautifully than me. Explain why naked flame is not used in step 5. This question is, I think you have seen it, you are known about it since your O-level chemistry. The basic theme is whenever you are going to heat any organic compound or any flammable compound, basically that is a highly flammable compound that catches fire very much rapidly, वहां पर हम नेक्ड फ्लेम नहीं यूज करते, हम वहां इलेक्ट्रिक हीटर यूज करते हैं, हम वहाँ पर बॉइलिंग वाटर यूज़ करते हैं, सो ऑन. सो वेयर द कंटेंट्स आर फ्लेमेबल और ऑर्गेनिक कंपाउंड. ओ लेवल में हम लिखते थे कि ऑर्गेनिक कंपाउंड है यहाँ पे, तो हम ऑर्गेनिक कंपाउंड दे आर हाईली कंबस्टिबल, तो हम वहाँ पर डायरेक्ट हीट या नेक्ट फ्लेम के साथ हीट नहीं करते. सो बेसिकली इफ आर, I mean, there are, not if. There is flammable organic compound होते हैं. तो यही जो आप स्टेप 5 में क्या यूज कर रहे हैं, what are you using in step 5? You are using same methyl benzoate. So basically methyl benzoate, the more appropriate thing is methyl benzoate is flammable in the mixture. In the mixture, this methyl benzoate is flammable or highly flammable, जो भी लिखना चाहे, but it is necessary to write it flammable. Organic compound are highly combustible or flammable, I mean. The next step, explain the purpose of transferring the liquid into step 6. Why we are going to transfer into step 6? हमने step 6 में क्यों गए? What is the step 6? Allow the reaction mixture to cool carefully, pour the liquid into the beaker. Why we are pouring it into the beaker? Why? Because we have added anti-bumping granules over there. ये एक broken porcelain डिश के पीसेस होते हैं यूजुअली, जिसको हम सिरामिक्स बोलते हैं, तो उनको फिल्टर आउट करने के लिए, टू फिल्टर आउट द एंटी बम्पिंग सब्सटेंसेस आर सॉलिड. एंटी बम्पिंग सॉलिड्स आर ग्रेनुलर्स. टू सेपरेट एंटी bumping granules or substances, जो भी आप लिखना चाहें, anti pumping solid or granules. That was the basic theme. Explain what the substance, what the student should to do, confirm that the mixture has been acidified in step 7. उसने step 7 में आपने acid ऐड किया था, HCl ऐड किया था, if I'm not wrong, yes, dilute HCl. तो वो कहता है कि how to confirm it. Whenever they are asking to confirm HCl, तो आप कोई भी उसमें इंडिकेटर लिटमस टेस्ट कर सकते हैं. तो लिटमस टेस्ट कर दें, कोई और इंडिकेटर टेस्ट कर दें. So perform litmus test. If it is red, litmus is red, mean HCl is in excess. Describe what you would expect to observe as a sodium benzoate mixture is acidified in step number 7. What you would observe, क्या देखेंगे? कोई गैस, प्रेसिपिटेट, कोई रिएक्शन मिक्सचर में तब्दीली, अगर आप हीट नहीं कर रहे हैं तो हीट चेंज, और जैसे मैंने बोला कि any vapors, any color change in the solution, or any formation of the precipitate, etc., etc. So where is the step 7? And yes, step 7. Here is the step 7. Acidify the liquid by HCl. Whenever you are going to acidify it with HCl, then what will happen? This is a solid, man. It was aqueous, right? It is a solid. It's a solid. This is solid, and it was aqueous. So upon the addition of HCl, there is the formation of the solid. And is there any color of this solid given in the question before?
White precipitate.
I don't know if it is given over here. I think it should be white precipitate, but I don't know exactly. I think white precipitate. I think. As there is no any other such like, so white solid or precipitate is formed. Yes, you can say white precipitate is formed, that is of benzoic acid. Zoic acid, this one. It's a benzoic acid formed over here. So benzoic acid. Suggest why it is necessary to cool the mixture before filtering in step 9. What is happening in step 9 basically? I told you this thing in the initial portion of the this paper, this question. Benzoic acid, that is also written in my book very clearly, that benzoic acid is not soluble in cold water. So make it fully precipitate, to make it out, to filter it out, to separate it fully as benzoic acid, benzoic acid is not soluble in cold water. So in this way we can extract it fully. So in the basic purpose is to extract the complete benzoic acid from that solution. Now the next thing is pure benzoic acid has a melting point 122 degrees Celsius. The product made by the student 1 has the melting point 119. ये melting point कम है पहले से. The student suggests the melting point of the product has lower than the expected because it contains some water. Explain what the student should do to ensure that the product no longer contain water. उसको क्या करना चाहिए कि पानी खत्म हो जाए? That is also a typical question and it has been asked
Heat.
many times. Heat till the constant mass. Right? Dry the precipitate or heat the precipitate. यहाँ पर क्योंकि precipitate है तो heat का word सही नहीं है. Dry the crystals. But the important thing is till constant mass. Till the constant mass mean it is ensured that the complete water has been evacuated. Now the next thing is calculate the maximum mass of benzoic acid that can be formed from this benzoate. Yes.
3 minutes रह गए.
Okay. So can you find it please? Let me know very quickly how much is going to be formed. 136 methyl benzoate, 122 from the balanced chemical equation. You can see that this is the methyl benzoate, 1 mole. So इन दोनों की अगर आप इन दोनों को ऐड करते हैं तो ये कट जाएगा एंड ओवरऑल जो रेशियो हमारे पास आती है 1 मोल ऑफ दिस कंपाउंड इज गोइंग टू मेक 1 मोल ऑफ दिस कंपाउंड. सो आई मीन दोनों की मोल रेशियो सेम है तो इनका मैं यूं लिख सकता हूं कि 136 ग्राम ऑफ दिस मिथाइल बेंजोएट इज गोइंग टू मेक benzoic acid, that is this is OATE benzoate ester 1 to 2 gram, and if I'm using 1.242 then x gram of acid will be formed, that is equal to 122 over 136 multiplied by 1.242. Quickly let me know the answer of this
1.114. 114.
114 नहीं लिखते हैं काफी. Now come towards the next one. Student 3 produces 0.82 gram of benzoic acid from this one methyl benzoate. Calculate the percentage yield. Maximum कितना बनना चाहिए?
Sir, 1.11.
बना कितना? 0.825 multiply by 100. That is called percentage. ये है expected
74.
yield. ये experimental yield, and here is 74%. That's all about this question that was basically taken from the past paper, P3 practicals, your past year practicals, and it was not very difficult. It was very easy. Thank you so much. See you next. Bye. Good day. Have a nice day.